So in part two of your review for your final exam, we're going to take a look mostly at chapter 2 on financial math. The review for this section, we're going to go from questions 12 through 21, and then part 3 will finish up the review. But 12 through 21 here is mostly on the financial math, and what I've done for the review is I've written down the formula that you have to use for each one of these problems, and I base it upon the highlighted unknown that we're solving for, sort of a definition of what the problem is about. This is a simple interest problem, and we are looking for the value of the account A after a 5-year period. So my final value of this account is we start out with $2,000 that we've put into the bank. There is one from my formula. My interest rate is 3.5%, and I always have to convert that to a decimal, and I'm going to let that money sit in the bank for 5 years. So I have the right formula. I've plugged in the correct values. I have 2,000 times 1 point. I'm going to add these two values together. The 1 plus the 0.035 times 5 is 0.175. And when I do that, I get 2350. My answer is choice B. So there's how you do that one from start to finish. Again, starting with the right formula, plugging in the values, and then grinding it out in your calculator. 13, you do not have to worry about. We're good to go there. Let's take a look at number 14. This is a credit card problem. And on your final, all of this will be given to you, meaning all of this meaning being what's the table values. You do have to be able to know how to find the finance charge. And the finance charge is your average daily balance times your APR over 12. Now, your average daily balance is the total, this value here that you owe on your credit card, divided by the number of days. So I added up all of these numbers. I added up the number of days in the billing month. So July has 31 days. My APR is 0.24. There's that value. I'm just looking at 1 month. I'm going to divide that by 12. So the average daily balance, these two values together are 627.45 times 0.24 over 12, and that would give me $12.55. There is how you calculate the finance charge giving a credit card table. Number 15, up next, we have a compound interest problem. So my compound interest threw me right to that formula, and I'm looking to see how much I'm going to have in an account under these conditions in the future. I am starting with $2,500. Let's say that's how much I made in my summer job. There's the one from my formula. The interest rate is 3.7%. I converted that to a decimal. Annually tells me how many times this money is going to be compounded. Annual means one time per year. And my T is 4 years because the money is going to sit in the bank for 4 years. So I have $2,500. 1.037 raised to the 4th power. So I have $2,500, 1.037 raised to the 4th power, and this is a value out of my calculator. So 2,500 times that number out of my calculator is going to give me my answer, and that is 2891.05. My answer would be choice D. Now, let's say you get 2891.72. You are off a few pennies. Always pick your answer that's closest on your multiple choice test. It's all in the rounding. Your math is fine. Your rounding might be a little bit off, so always go for that closest answer. Let's take a look at number 16, which is basically the same problem with the numbers changed. We're talking about a compound interest problem. That's why I chose that formula. I'm looking for the total future amount. Under these conditions, knowing that this summer job I earned $2,000, I put the money in the bank at 4.1% interest, 0.041. I'm going to get an account where my money is compounded monthly. My N is 12, and I'm going to let it sit in the bank for 4 years. So there are all of my numbers in the formula. From here, it's time to grind it out in the calculator. 0.041 divided by 12 is 0.03417. And I'm going to raise that to the 48th power, 12 times 4. My future amount is 2,000. 1.003417 raised to the 48th power is 1.17789. My future amount is 2355.77. My answer is choice B. So there is how you would do that one from start to finish, recognizing what type of problem it is, compound, and then plugging in the numbers into the formula. And you're set. Let's take a look at number 17. For this one, we are working on one where we're looking for the effective interest rate given a nominal interest rate. So here's my conversion formula for this one. My nominal interest rate is 4%, compounded monthly, that's going to be 12. My T for this formula is always equal to 1, and then I'm going to subtract 1 at the end. So what I have here is 1.00333 raised to the 12th minus 1. This value in my calculator is 1.0407 minus 1. And I'm basically finished here. 1.0407 minus 1 is that value. Since this is a percent, I have to move the decimal over 2 places. My answer is 4.07%. So there's what I would have for a effective interest rate calculation given the nominal interest rate. For number 18, we are solving for a present value given that I have $10,000 annual compounding. So this one, I'm using this compound interest formula, except I'm working backwards to solve for P, the present value. In the future, I want to have $10,000. I want to know how much I have to go to the bank with today to make that goal a reality. So my interest rate is 0.053, compounded annually, and I'm going to let the money I have today sit in the bank for 10 years, and it's going to grow into $10,000. So I have $10,000 in the future. Today, that's what I'm trying to figure out, my present value, how much I have to go to the bank with. 0.053. 1 times 10 is 10. 0.053 divided by 1. So I have 10,000 is equal to P. I take out my calculator and I say 1.053 raised to the 10th power. And I get 1.676. I divide both sides through by that. And I have a P value when I cancel those guys out at 59.66 45. So for today, that's how much money I would need under all of these conditions to get a future amount of $10,000. So there's how I do number 18. Number 19, there's not any calculations to this problem. Let's take a look at this one. We have a person, John, that wants to have a goal of $10,000 in the future. He goes to a bank, and the bank offers an interest rate at 4.6%. And he's thinking, okay, I need a certain amount of money today to make that happen. He goes to another bank, and the bank says, we'll give you 4.7%. And he's thinking, how much money do I need today to make that happen? Well, this amount here is going to be lower because his interest rate is higher. He doesn't need as much money today to get to his goal because the higher interest rate is going to make up for it. So he doesn't need as much money in this bank with that higher interest rate to reach his goal. That's how the problem works. Number 20, this one. We want to figure out on a monthly payment how much money of this monthly payment gets filtered off to the interest and how much money gets filtered off to the principal, because we have two piles we have to pay down, the interest amount and then the actual loan amount, the principal. So we have two piles that we have to pay down each month. The amount that goes towards paying off your interest pile is calculated by seeing how much we owe on the loan. $105,683.56. We're going to multiply that by the interest rate, and we're just looking at 1 month. So out of that $877.60, $506.40 goes towards paying off the interest beast. Now, what's left over for the principal is you take your monthly payment. This is easy. The interest beast has gobbled that much up, and what's left over goes towards paying down the principal, the amount that you borrowed. That is my answer right there. So there's the process in that much goes towards paying off the interest, that much goes paying off the loan amount for that particular month. So the last problem for this video is problem 21. And problem 21 is all about calculating your monthly payment under a certain situation, $5,000 that you borrowed under these given conditions. So how much will your monthly payment be to pay off this loan? Now, let's say we have $5,000 we put down on a car. We borrow the rest, $21,600. My interest rate is 4.5%, 0.045. I'm looking at 1 monthly payment. My N is 12. Now from here, I have 1 minus 1 plus 0.045 over 12 raised to the negative 12. My N is always 12, and I have 4 years to pay off that loan. So that's a beast of a formula with a lot of moving parts to figure out what goes where. Here's the loan amount for the car that I have to pay back. Here's my interest rate. My N is always 12. I have 4 years to pay it off, and there are all of my ones from the formula. So my monthly payment, multiplying the two values up top first, that 21,600 times those values would give me 81 upstairs in the numerator. I just blocked all of that off, and then downstairs I have 1 minus 0.045 divided by 12 plus 1 is 1.00375, and I'm going to raise that to the negative 48 power. So I have 81 upstairs divided by 1 minus 1.00375 raised to the negative 48 power is 0.8356. And when I divide 81 over 1 minus that value, I'm going to get 492.70. My answer is choice C. Now you're like, well, you missed it by 14. That's all in the rounding. So I picked my closest value. I probably missed some rounding right about there, but that's going to be your closest value on your test. So there's how you would do the monthly payment. Part 3 is up next, where we take a look at statistics and voting methods.